Good day and welcome to this introduction to Klimacheck Level 1 training. I look forward to introduce you to the opportunities in predictive maintenance based on performance analyzing. My name is Claes Bergloff and I started Klimacheck 2004 based on patents and experiences that actually originated already in the mid-80s. Nowadays I'm responsible for the R&D and try to maintain contact with key customers around the world. So, to give you a background, as mentioned, I started working with performance analyzing in 1986. And that was because of the heat pump boom here in Sweden, where people bought heat pumps to reduce their energy costs. And this was very different from when you buy refrigeration cooling plants, because then you buy them to get the temperature. But heat pumps are an investment to reduce cost, and then there is much more focus on the actual performance, because people compare the bills. Did they decrease as expected? If they did not decrease as they assumed they would, there was complaints. So the contractor and the manufacturer got into problems. So I was involved in a lot of troubleshooting and trying to explain why the performance was as it was and what could be done to improve it. And there was no good methods available. So based on the thermodynamics, I developed this method that has been on the market since then. But in 2004, I formed Klimacheck, and that was to redevelop the product based on the new technologies with PCs and also when it comes to sensors. There have been a lot of development between 1986 and 2004. And already in 2007 we introduced the cloud-based monitoring. So we have a long experience today of cloud-based monitoring of air conditioning, refrigeration, heat pump plants all over the globe. We have achieved quite a bit of recognition. 2011, we were appointed WWF's, the World Wildlife Foundation's Climate Solver Award, due to the huge energy savings that can be achieved by making existing air conditioner, refrigeration and heat pump plants to work as they actually should do from the beginning. Currently, there is very little focus on optimization in the field. So this was recognized by the Climate Solver program. We also has been awarded the recognition of the ASHRAE Energy Award 2018, where Klimacheck was a part of SAND's Casino's energy optimization program in Macau. And also Banner Health has received awards for their energy efficiency program based on Klimacheck analytics in US. So today we see that the market is growing for predictive maintenance, and as more and more sensors are already in the field, when you buy a chiller, there is a lot of sensor in it. The BMS has additional sensors. So very often all sensors are in place, or there is just the temperature or the power meter missing. So you can add to existing and then use the Klimacheck to analyze the data. But we continuously supply turnkey solutions when the existing system is not suitable for integration. So currently we are monitoring a huge number of systems in all applications of refrigeration processes. So it can be dehumidification, heat pumps, cold stores, shipping, you name it. We are monitoring systems of all kinds. So, and we have a lot of big customers that are introducing Klimacheck as their way of monitoring their air conditioner, refrigeration, heat pump plants, because it's an unbiased method that can be used on any brand and giving the same information regardless of who is the manufacturer. So basically we have two platforms. One is the Klimacheck Online, which is the cloud-based technology, and one is Klimacheck On Site, which is the PC software. So the PC software is suitable for troubleshooting, energy audits, and so on when you are doing a measurement over a shorter period of time. It can be hooked up in the matter of half an hour or an hour to virtually any air conditioner, refrigeration, heat pumps plant in the world, and collects all the data on the same level as you have in a test rig in a manufacturing site. You have all the details of the system and how it operates. But it is intended for shorter period of measurements, so you cannot, in a good way, use it for months of measurements. So it is for shorter periods of time. Whereas the Klimacheck Online, where data is brought up to the cloud, where the analytics are done, it stores data for any amount of time. And of course, can also be used for portable equipment, collecting data for a baseline of a month or several months. So these systems can be overlapping and interacting. But the target is, of course, to as larger systems that are monitored for a long period of time. Certainly, Klimacheck Online is the future where data can be stored for a long period of time, and it includes the energy analytics, not only the performance at any time. So the whole idea is, of course, to take the data and make information out of it. When there are pressures and temperatures and so on, they require a lot of time to make information out of if you do it manually. If you take your pressure enthalpy charge and you take the data available on a chiller controller or so, it can give you a lot of information, but it takes a lot of time, and it's not realistic to do it more than at a couple of specific points. Whereas when you bring the data to an expert system like Klimacheck Online, you can have this data in real time, calculating continuously how the performance is changing, taking into account what happens at different operating conditions and so on. So it gives you a huge amount of information, and any of these parameters that you evaluate can be triggering an alert if it's deviating from optimum performance, which opens a totally new world when it comes to predictive maintenance, where we can actually give an alert for any problem in the system. And as I mentioned before, we are totally flexible. We can supply systems with all the sensors. You plug them in, and as soon as they are powered up, you have applied the sensors, data goes to the cloud, and it's monitored. Or you can also have where there is a local data collection system collecting all the data in the BMS, or collecting data from the BMS and transferring it to Klimacheck Online with server-to-server communication. And it can also read back data. So we can supply gateways that are taking data on Modbus, server-to-server solutions, or standalone where we supply a total kit. So it's total flexibility on how the data is brought to Klimacheck Online. But then comes to the information. Traditionally, our industry have used alerts, alarms, to know when you go there to fix something. This is extremely inefficient because of everybody knows that when it gets very hot, then there is a lot of problems. And that is not due to that the problems occurred at that time. It's because of they are noticed at that time. But this, you collect problems over a long period of time, and then it comes a peak in outdoor temperature, and all these problems becomes a pain for the customers. So they call for service. Whereas these problems could have been detected much earlier and corrected before they cause any pain. So this is the idea with predictive maintenance, is to get away from the reactive maintenance where people go on an alarm or a discomfort from the customer. So the idea is, of course, have your systems monitored. Anytime your refrigerant charge change, anytime your compressor efficiency change, condenser efficiency, evaporator efficiency, get the specific alert that is telling you that you have a problem in this component, need to be fixed. Then it's easy to plan the measure. It's not urgent. You need to take care of it within a period of time, depending on what kind of problem it is. And then you can make a plan. You have the right equipment when you go to site, and you fix the problem, and you can verify that the problem was actually fixed by looking at Klimacheck online. Performance analytics on air conditioner refrigeration. As I mentioned, it has been proven since the early mid-80s. And today we have third-party verification from National Renewable Energy Laboratory in US. That's a part of Department of Energy. We have from the Swedish accredited test facility RISE. They have tested and evaluated the method both in theory and in practice in their laboratories. So there is a lot of verification of that the method is relevant and gives accurate information. We supply customers all over the world. It's 300 megawatt cooling in the casinos in Macau in China, several hundred megawatts of cooling in hospital chains in US, hundreds of supermarkets in Europe. So it's a lot of experience that have been gathered on our servers today. We work with partners all over the world. We identify people that want to change how service and maintenance and optimization is done. So we have partners that are contractors or consultants using Klimacheck in their daily work. We work with suppliers, manufacturers of components and equipment. So for example, Carrier, they are using Klimacheck as a portable system all over Europe to troubleshoot and optimize systems and to define baseline performance when there's a request to replace old chillers. It's very useful to know the efficiency and performance of the existing system to design the new system correctly and be able to do ROI calculations on the replacement. We have customers like Copeland, world leader in compressor manufacturing. They are using Klimacheck for their application engineering and also for their demonstration and development test rig of CO2 in US. They have installed Klimacheck on that. So we work with the OEMs both for application engineering and development test rigs and production test rigs. We also try to promote energy efficiency and competence building. So we work with UN organizations, for example, for competency, for capacity building, I should say, to build competence in energy efficiency, because there is a global challenge to achieve efficient operation of systems and reduce the failure rates, of course. When a cold store fails, it can be very costly, not only from the repair point of view, but it can also cost a lot of perishable food that is destroyed, perishable goods that is destroyed. Supermarkets have high costs when their cooling system fail. A data center has a high cost when their system fail. So there's a lot of incentives to try to change how things are done. And this is, of course, coming under extensive pressure now with the whole climate change debate, where air conditioner, heat pump and refrigeration use about 20% of the global electricity. It's estimated that about 4% is used by food and drink industry and about 4% used by supermarkets. So these are big sectors. Air conditioning is the biggest one, and in many regions, air conditioning will be defining the load in the grids, which makes it a really key element in the future to make sure that you have efficient air conditioning systems, because they require additional grid capacity, production capacity, if they are inefficient. And when these systems are evaluated, there are many surveys around the world showing that they are not working efficiently. Our experience, as well as many others, is that there is 10 to 30% easily achievable savings in our industry by tuning system, fixing problems. These are not replacing the systems. It's not major investment. It's just fixing the problems and adjusting controls on these low cost. So that is actually the low-hanging fruit in our industry when it comes to energy saving, is to make the system work. That's much, much more cost effective than replacing units to achieve a certain reduction of energy. Traditionally, in our industry, there has been a significant focus on balancing of ventilation, balancing of the hydronic systems. So people focus on that which is kind of nearest to the users. Whereas the production of the air conditioning refrigeration, it's in the basement. It's a machine that is hardly anybody understands, and it's assumed to work as it's rated. Whereas no system works as rated. They work differently in the real life situation. They will very rarely operate at design conditions. So to make sure that your system is working well on the actual conditions, that's where you can really improve. And this has been neglected because of the way industry has worked. Where there is a specification, normally the refrigeration mechanics, they commission the plant and then they leave. They have no responsibility to make the system operate efficiently over the varying operating conditions. So nobody else does it either. So we have a situation where there is a plumbing contractor involved, a ventilation contractor involved, control contractor involved, and the refrigeration contractor involved. And nobody's responsible for that the operating conditions for the air conditioning, refrigeration, heat pump system is good. So there is a tremendous potential to save by making them work well. And most of the problems can be avoided if you make sure that your system is operating well. And long before you have an alarm, you can see that this is going to cause you problems in the future if you do not adjust your system to operate better. So today, it's only the tip of the iceberg that are observed. Nobody is looking at the total picture. And that is what Klimacheck does. It opens the black box and you can see the whole iceberg. So you can tune your system to work well. And for that you need the new level of information that Klimacheck give you. So the trend is, of course, to move it from scheduled maintenance visits where you take some protocols, tick some boxes. These are not extremely useful. Very often you can, if you study them closely, you can see that there are problems. But as nobody spend the time to go back and track every number and what it means, they very often, it's just a procedure to do to fulfill the contract. And a lot of things are missed, and there is a lot of lacking information. Today, it is possible to use Klimacheck to collect all the data and get it into a visualization which really immediately point you to where you might have a problem. Where do I need to look? And you can compare from historical data and compare how it is now and see where you have any deviations. And of course this can be automatically if you have data in the cloud on a server. This can be monitored. Now there is a change. Your compressor efficiency is decreasing and you can get an alert to plan a visit to identify what it is and make a repair or replacement long before there is a failure and customer complaints. So this dashboard actually contains all the information you need to confirm if your system is operating well. It contains a lot of information. It's the very graphical speedometers showing you what the efficiency is compared with a loss-free process. So these will be the same for any chiller. The references is based on the temperature condition is operating between, and these efficiencies, they stay much more stable than values like COP or efficiency in kilowatts per ton. These are changing, the kilowatt per tons and COP is changing with operating conditions. Whereas the system efficiency index, the value to the far left, that is comparing the total efficiency of your system with how a loss-free process would operate between the temperatures that it's operating within. So it gives you a very good benchmark, and it's much less dependent on your operating conditions than the conventional benchmarking parameters. And then of course energy, that is what you are paying for. So to have a good tool to optimize your energy consumption is very important. And when you have all the performance data, you can see the impact on efficiency of any change you do in your system. So you can identify the faults, you can find energy optimization opportunities, and when you do your adjustment, you can see the impact on your energy consumption. And as most plants are working dynamically over varying climate conditions and loads, we need to relate the information to the outdoor temperature. So the yellow graph is showing your outdoor temperature, and the pink bars is showing the energy consumption per 24 hours or per hour, whatever you select. And then you have a baseline period where data is collected, and the service builds automatically an energy signature, which is based on the historical consumption at each outdoor temperature. Then you do your optimization, and you run a new statistics based on post you have implemented the measures. So then you can see that between this blue line and the pink line, that is your energy savings. And before the optimization, that's what you wasted in energy by running your system at the less optimum than what was possible. Of course, refrigerant leaks is a major issue. Many of the refrigerants has very high global warming potential, and if you don't correct that, you are causing a lot of climate impact, but you're also increasing your energy consumption, and it will result in failure. And there are, of course, gas warning systems that can detect leaks, but everybody who has been involved knows that that's a major challenge. Because of that, the refrigerants are heavy, they will fall to the ground and be ventilated away. So you have to put your gas warning detectors under where the leak is expected. If you have a big plant, it can be impossible to cover the plant in anywhere near to get a good coverage of where all the leak can occur. So gas detectors is one way of detecting leaks, but indirect leak detection, where you monitor the parameters in the system where that are affected by the refrigerant charge, is a much more reliable way of detecting leaks, because of if I change my refrigerant charge, it will affect my operation, and you can detect these values very accurately. So the parameters you monitor will vary depending on what type of design. I mean, we are monitoring any type of vapor compression cycle, so it could be a supermarket, or it could be a chiller, or a heat pump. So there are specifics to different type of designs, but basically leakage will always affect your operation, and you can detect those. So when we are looking at it, there are the subcool will be affected by refrigerant charge, the superheat, the evaporation, the cycling of the compressors, and the energy signatures. So we have many ways of detecting the leaks, and which one will be give the earliest warning will depend on which type of design it is of your system. So we have different methods of identifying leaks as early as possible. So then, just to give you some case studies that are publicly available. One of the recently described case studies is Banner Health in US, which there is under a link there is of the webinar here. There is actually an educational webinar on how you implement a systematic approach to energy optimization and predictive maintenance of a chiller plant. So they have, it's totally 25 buildings that they are monitoring. Phase one, which is the part that was finalized when this webinar was produced, it was 10 buildings. So they achieved the saving of $3.8 million on annual basis in this project, which was of course very valuable from the saving point of view, but it also reduced the number of complaints and the problems in the hospital. A failure of your cooling system will cause that you cannot make the surgeries because the humidity increases, and you cannot run your expensive MRI and this type of equipment that all depend on the cooling. So it's critical to maintain temperature and humidity in these applications. So they did a lot of energy savings, and one conclusion that I think is very relevant is that they, in 6 months after that they have finished the recommissioning and the measures taken on these 10 buildings, they had 24 issues that increased the energy consumption with 10 to 15%, some even up to 40%. So we are talking on a moving target when we are looking at monitoring plants. There are things happening all the time, and the air conditioning refrigeration plants, they are affected by things happening in the ventilation, in the plumbing. They're affected by the controls. So you actually need to keep a close watch on your system, and when something happens, take action before it has caused waste of energy or failures. Another case that has been widely published is the Sands Macau. That's 3 casinos in Macau that have together more than 300 megawatt of cooling. And they introduced an ambitious chiller optimization program, where one of the first steps they took was that they installed Klimacheck to identify what measures would give the best savings and to ensure that each measure delivered what it was supposed to do. So they actually saved $4 million on the operation of the chiller plants, and they reduced the cost of maintenance significantly. And in spite of taking significant measures, the total ROI was less than 1.6 years. So that was the introduction to give you a flavor of what can be achieved by using Klimacheck systematically to make air conditioning, refrigeration, and heat pump plants more efficient. Thank you very much.